As we continue this series of talks on the key role of science in the new evangelization, I would like to thank you very much for your presence. This presentation is entitled Learn an Urgent Lesson from a Chaotic Fig Tree. Here it is shown how a recently discovered chaotic fig tree and other such trees provide relevant lessons to increase our faith in consonance with what is written in the Bible. The thesis of this work is that we humans, with the gift of a soul, may learn from recent advances regarding natural complexity in order to find the peace of Christ and share the good news in a noble way. As may be readily verified, and to test some connections for later, the fig tree is an important and mysterious symbol in Holy Scripture. It appears first in the fall of Adam and Eve, in the way they covered their nakedness using fig leaves. Throughout the Old Testament, it is a consistent symbol, together with the vine, for the behavior of the people of Israel, for they could only enjoy such desirable fruits if they would follow God's law. The fruit is also a notorious healing symbol, as prophet Isaiah administered a poultice of figs in order to cure the ailing good King Hezekiah after the sun reversed and retraced its course. In the New Testament, the first mention of the tree is in the story of Nathanael, one of the 12, who first said, "What good can come from Nazareth?" and then yielded to Jesus Christ only because he told him that he saw him under a fig tree. Such a symbolic tree also appears prominently in the parable of the barren tree placed in the middle of a vineyard and given another year to produce fruit, and in the odd and seemingly out-of-character cursing and killing by Jesus of a fruitless fig tree that we are told bore no fruit because it was not in season. Additionally, the fig tree is also mentioned in Jesus' eschatological discourse when he explains that such a tree, with a tender branch and budding leaves, would signal his return, a parable that ends with Jesus' mighty words that heaven and earth will pass away, but not his words. This presentation aims to show how modern science, and in particular chaos theory, provides suitable elements that allow us to further understand these passages, leading to urgent pleas to conversion and relevant reminders about us needing to be vigilant while we await Jesus' return, loving God and one another. Hailed as one of the most important scientific achievements of the 20th century, chaos theory provides poignant symbols and precise semantics. The prototypical equation used to illustrate the well-established theory is the logistic map. xk plus 1 equals alpha xk times 1 minus xk. Here, x may represent the size of a normalized population from 0 to 1 of, say, rabbits. K and k plus 1 are subsequent generations, and alpha is a parameter that may take values from 0 to 4. The logistic map gives rise to a symmetric parabola obtained by plotting the quadratic equation one generation against the next. As is seen here, the graph peaks by the middle at a height of alpha quarters and exhibits an increase if xk is small, but a decrease if it is large. The name of the map reflects the fact that such a behavior is logical in many situations regarding resources. If there is a little of something, there is a tendency to increase. But if there is too much of something, then the trend is to decrease. Aided by the one-to-one line y equal to x, we may compute a sequence of iterations of the map starting at an arbitrary location x0 until it converges, following the vertical horizontal lines, to the ultimate fate of the population, x infinity. As is seen here, for a value of alpha equal to 2.8, the population increases steadily and then spirals into the non-zero intersection between the parabola and the line. But the ultimate x infinity is not always the same and depends exquisitely on the parameter alpha, as summarized next. When the parabola is below the line y equal to x, that is, when alpha is less than 1, as shown here for alpha equals 0.7, the ultimate x infinity equals 0. Regardless of the initial population size, repeating the dynamics, following the vertical horizontal lines, leads to the same destination, the extinction of the rabbits. 0 is hence termed a stable fixed-point attractor for the process. When the parabola crosses the line and alpha is less than 3, x infinity is given by the non-zero intersection between the line and the parabola, as illustrated in motion before. Now, a small number of rabbits does not lead to their extinction, but rather to a constant population size equal to alpha minus 1 over alpha. The origin, which previously attracted all the dynamics, now repels, and this happens as the slope of the parabola at the origin is too steep, that is, it is more than 1 in magnitude. But this is not all that may occur. When alpha exceeds 3, what happened to the origin also happens to the non-zero intersection between the line and the parabola. It no longer attracts, but rather repels, because the slope of the tangent there is too steep. As shown when alpha equals 3.2, 0 repels, and although the lines appear to point to the non-zero intersection, such also repels, and the iterations do not settle into a single point, but instead end up oscillating indefinitely between two values x infinity 1 and x infinity 2, making up a square, and hence defining a so-called periodic attractor. If alpha is further raised to 3.46, oscillations between two populations are no longer achievable, but instead the dynamics settle into a repetitive pattern every 4 generations. X infinity 3 to x infinity 4 to x infinity 5 to x infinity 6 and back, making up a shape with 8 segments that travels in and out as shown. In a surprising manner, this trend continues as alpha increases, and the logistic map defines increasing bifurcations that encompass all powers of 2. This happens as alpha reaches a limiting alpha infinity value equal to approximately 3.5699. After alpha infinity, the dynamics may be either repetitive, that is, periodic, or non-repetitive, that is, aperiodic. As an example of the latter, when alpha equals 3.6 and 4, the iterations yield uncountable strange attractors that do not settle into any repetition. As such sets also have the property that nearby initial points end up diverging from one another, they are also known as chaotic attractors. When alpha equals 3.74 or 3.83, the dynamics result in oscillations that repeat every 5 and 3 generations as shown. As if by magic, the curvature of the parabolas is such that the vertical horizontal lines synchronize to yield eventual repetitions. Remarkably, there are many such periodic oscillations for great many periods after alpha infinity, all intertwined with chaotic behaviors. When all is computed, the diagram of bifurcations, shaped as a tree when rotated 90 degrees counterclockwise, summarizes the incredible behavior of the deceptively simple logistic parabola. Here in the horizontal is alpha, and in the vertical x infinity. For alpha between 0 and 1, there is the extinction of the rabbits in the straight root of the tree. For alpha between 1 and 3, there is the fixed point main branch given by the equation alpha minus 1 over alpha, leading to the upper tip at 2/3. Right after, there are repetitions every 2 generations, then every 4, and quickly every power of 2, drawing bifurcating branches up to alpha infinity. Then there are chaos and repetitions intertwined in the tail of the diagram. Notably, the diagram contains periodic behavior as seen in white bands that encompasses all natural numbers and great many non-repetitive behaviors, something impossible to foresee prior to the advent of modern computation. Here is observed in more detail the tail of the diagram. As is seen, strange attractors, plotted as vertical collections of dots, are very common after alpha infinity. Such periodic sets turn out to define dusty attractors, as there is empty space between their points, as indicated by distinct shades on the vertical lines. As is observed, within all periodic white bands, there are noticeable buds, like the one here in the middle of period 3. When such a bud is magnified, one surprisingly notices that it includes a small copy of the shoot of the tree. And, as in the infinitely many buds of all periods, such a generic repetition happens, this remarkable fact leads to the conclusion that the bifurcations diagram exhibits utter self-similarity ad infinitum, something never seen before the sprouting of the chaotic tree. The diagram of bifurcations includes also a multitude of multifractal thorns that correspond to spiky distributions of dusty sets within the chaotic tree. The first such a set, shown here, occurs precisely at alpha infinity when there are infinitely many bifurcations. A histogram of the dynamics at such a location exhibits imbalances in the spikes and holes between them, which may be defined via a cascade that includes both features. Remarkably, there are thorns galore by the ends of all white bands of buds corresponding to the infinitely many periods encountered in the tail of the diagram, and the object would prick us at infinitely many places. Believe it or not, the tree of bifurcations is also known as the Feigenbaum tree, or the fig tree in German, in honor of Mitch Feigenbaum, who proved, for the first time, some universal properties about the object. It happens that the bifurcations occur in an orderly manner, both in their openings and durations. As is seen here, the x-bar equal 1/2 line crosses the bifurcations in an alternating fashion, and the openings d sub n from such a line to the other side decrease such that the ratio from bifurcation to bifurcation tends to the number f sub 1 minus 2.50, the first Feigenbaum constant. Similarly, the duration of the bifurcations delta sub n decreases quickly, and the quotient from one bifurcation to the next tends to the number f sub 2, 4.669, the second Feigenbaum constant. These assertions show that there is order in the pathway to chaos via bifurcations, but such does not imply that chaos itself is ordered and predictable. Feigenbaum's numbers turn out to be universal, as they hold for countless equations that give rise to other chaotic trees. The iterations of functions with one peak, as the ones depicted here and related to the simple equations shown, always yield, by increasing alpha, a straight root, a tender branch, bifurcation branches, and, in an intertwined fashion, periodic branches and the dusty foliage of chaos, which then, figuratively, correspond to fig leaves. In all cases, the openings and durations of bifurcations, and also within all their buds, happen precisely at the speeds given by f sub 1 and f sub 2. These ideas turn out to be relevant in several fields of science, including biology, ecology, chemistry, physics, and economics. Among the most pertinent results are discoveries made and inspired by Albert Lichavet's work on how convection happens, that is, how the heating of fluids leads to turbulence. Surprisingly, it turns out that alpha, at the very pace of the second Feigenbaum constant, yields the heat that needs to be added to a fluid, whether liquid helium, mercury, or water, so that qualitative changes are observed. If little heat is added to a fluid, its internal temperature does not even change, and such corresponds to the root. But if enough heat is progressively added, first the fluid becomes steadily warmer, as in the main branch, and then it exhibits temperature variations as it starts to move in response to the additional energy, as in the bifurcations. The first bifurcation corresponds to a case where the warmer fluid, close to the source, becomes less dense and rises to be replaced by a colder fluid that, being more dense, sinks, making up a repetitive cycle. As alpha keeps increasing, new repetitive stable behaviors settle in response to the additional heat, and such happen at the pace given by f sub 2. And if the heat is increased a lot, it is best not to put a finger inside the fluid. In order to further appreciate some of the subtleties of chaos, it is pertinent to study in some detail what takes place in the summit of chaos when alpha takes on its maximum value of 4 and the logistic parabola ranges from 0 to 1. At such a maximum heat, the dynamics wander on a compact strange attractor that appears to encompass the entire interval from 0 to 1, as shown. However, this is not true, as unstable extensions of the Feigenbaum tree, shown here below, need to be excluded. For instance, the value of x equal to 3/4, corresponding to the extension of the original tender branch in the non-zero intersection of the line and the parabola, cannot be in the ultimate attractor, for starting at such a value returns 4 times 3/4 times 1/4, or 3/4, the same value forever, yielding a repetition every generation, which is clearly not chaos. Values corresponding to any period need also to be excluded, as the ones that repeat, say, every 3 generations, as shown next. As indicated in this diagram, not only do the 3 repeating values need to be excluded, but also all other points within the domain that are in the past of such values, that is, their preimages. Here k denotes a generation, with 0 and positive values indicating eventual repetitions, high, low, medium, high, low, medium, etc., and with negative values denoting points that are not yet on the periodic attractor. This diagram turns out to be easily computed, as there are 2 values in the past for any single value in the present. As such, the highest repeating value shown in generation 0 is associated with 2 preimages found reading the parabola backwards, just drawing a horizontal line at such a value and finding the intersections as illustrated on the right. And if such a process is repeated on each point, it yields a tree in powers of 2, a countable collection of points that hence cannot be part of the strange attractor. At the end, many similar trees containing a countable number of points and corresponding to the values of any period need to be excluded from the interval from 0 to 1. 2 of period 2, 3 of period 3, 4 of period 4, and so on. As a consequence, the strange attractor is a rather dispersed and dusty uncountable set, as it is equal to the whole interval from 0 to 1 minus the infinitely many trees branching densely in the interval, like the one here that has preimages all over the interval from 0 to 1, just 13 generations to the past. All this turns out to be very relevant because there is a collection of initial values that altogether escape the dreadful consequences of jumping forever in high heat, for such a return dynamically, even if improbably, to the root of the tree. These are the preimages of zero that find their way despite the most implacable convection, which, by arriving precisely to the middle at generation zero, next go to one to finally rest at the origin. Note how this process paints a remarkably consistent, even if inverted, square root. Observe how these observations reminds us of the concept of purgatory and the associated parable of the weeds. For the wheat, in the preimages of zero, is finally surrounded by undesired behaviors that unfortunately end up forever in fire. Note how the ideas also reminds us of the three exalted friends of Prophet Daniel, dancing in the highest heat without consequences, and the protection of the prophet himself in the lion's den. As Jesus spoke in parabolas, for such and parables are the same word in many languages, this notion suggests, I think, some plain common sense reflections. For instance, they reaffirm that it is best to avoid chaos and its truly infernal turbulence, because missing the middle point, the point, even by a small distance epsilon, has as shown tragic consequences. As the mid value is not a half, the next value is not 1, but something less. And the following value is not 0, but more. And although the dynamics remain close to 0 for a while, the original small error amplifies into the unpredictability of chaos that, in all probability, misses the origin. For the famous butterfly effect, expressing the incredible sensitivity of chaotic dynamics to the start of the iterations, does not provide us with good options at all, and instead leaves us irremediably trapped in an empty strange attractor in which, as some prophets have clearly explained, we may find no rest. As such, we may learn from these notions, and not only in relation to sharing our rabbits, that it is best for us to come down the chaotic tree, just as the little man Zacchaeus did, and strengthen our errors, that is, our sins, hence diminishing our intrinsic hits to find the straight root and accept God's salvation. As convergence to the root is associated with little parabolas that do not cross the line, these ideas also invite us to abandon ourselves to the chosen threshold, y equal to x, that is, to Jesus Christ himself, seen geometrically in the cross x and his crucified silhouette y, who we are told is the door and the narrow gate, and how narrow it is in the summit of heat, so that we may arrive to the love of the Father in the gentle state x infinity equal to 0, which consistently denotes the saintly origin, now with a capital O, representing his halo. To say it yet in another way, the precise symbols from chaos theory reminds us that it is best to move away from the implicit nonlinearities that happen when alpha is greater than 1, and into mild slopes at the origin. For amplifying without proportion takes us into the shoot of the tree, thorns, and eventually into dust, which represents death. For this is the prescription regarding our actions, even if chaotic features are wired into a healthy brain. These ideas represent unexpected, yet rather accurate connections between the geometric symbols and universal concepts of the science of chaos and our Christian faith that provide an unforeseen invitation to reconciliation and love, consistent with the very logistic of salvation in accepting Jesus Christ. However, the modern advent of the symbolic fig tree suggests even more. Could it be that the scientific Feigenbaum, even if springing 20 centuries later, has a prophetic meaning? Could it be that we are being given a merciful clue that illuminates the ancient word via modern science? As we recalled earlier, Jesus cursed an allegoric fruitless fig tree and it consequently dried up to the root. Like the biblical one, the chaotic fig tree lacks any visible fruit and contains instead leaves of dust that properly reminds us of the leaves Adam and Eve used to try to cover their shame, and God's famous edict to Adam, "Dust you are, and to dust you shall return." As such, this tree is consistently cursed above the root by the inherent disobedience of crossing the threshold y equal to x. As the scripture hints, that we may see it for ourselves, this fig tree, and many other chaotic ones, has a tender branch, as curiously written in singular in the original Greek, and literally contains a multitude of bursting buds in their periodic bands. As climbing the shoot of the tree symbolizes our progressive detachment from the root of goodness, and as the trees also contain multitudes of equally symbolic thorns, it is sensible to ask ourselves, if we pay attention to Scripture, if these ideas are a preamble of a near summer, of a near return, as Jesus expressed it in his eschatological discourse. For in the bifurcations diagram, it may also be appreciated why the axe lies at the root of the trees, as expressed by fellow hydrologist John the Baptist. Why it makes sense that the root is the logical location where Jesus saw the future apostle Nathanael, that is, under the fig tree, and why Jesus said to his astonished disciples that they could also curse and kill the fig tree. No doubt in the same way he rebuked the wind, whose ruler, the devil, is potently symbolized by the ratio 2/3 equals 0.666 ... as found by the end of the first bent branch of the tree. Although by divine design the notions herein and other repeating chaotic calamities such as wars and rumors of wars, famines, tribulations, and persecutions do not allow us to set exact dates, they help us, however, to sketch some options we have which heighten the goodness of being vigilant and behaving properly in preparation for a triumphant return. Such options are order or disorder, simplicity or complexity, serenity or turbulence, peace or chaos, decreasing, as John the Baptist did when he knew about Christ, or increasing, believing that we are more than him, following God's way below y equal to x, or choosing our way above y equal to x, abandonment or selfishness, obedience or rebelliousness, to receiving consonants, blessings or curses, and ultimately to rest eternally in heaven or to wander forever in hell. I would like to share now a song called, in German, Feigenbaum's Parable, or the Parable of the Fig Tree. Foliage of disorder trapped in empty dust jumps astir forever, enduring subtle trust. Crossing of the outset, leaving faithful root, looming tender offset, failing to yield fruit. Cascade of bifurcations, increasing heat within, inescapable succession of branches bent by wind. Sprouting of dynamics, attracted to the strange, or infinity reminding, at the origin, the flame. Could it be, O my friends, that science offers a rhyme? For a rotten tree foretells the very advent of time. Could it be, O how plain, that nature extends a call? For all parable proclaims the crux in growing small. In the midst of chaos there is a small gate leading to find rest. In the midst of chaos there are loyal paths inviting to a dance. On top of the fig tree there is a key point that runs to the core. On top of the fig tree there is a clear light that averts a fright. In the midst of chaos there is sleeping game, discerning the way. In the midst of chaos there is a fine well, watering the brain. On top of the fig tree there is a clean frame that cancels the blame. On top of the fig tree there is mighty help that shelters from hell. Now, very close to the end, I would like to remind you of other coincidences of faith you may visualize based on the concepts of science in this talk. It happens that the four states in Jesus' famous parable of the sower may be seen in the Feigenbaum tree. While the three fruitless scenarios correspond to chaotic, periodic, and fixed points within the shoot of the tree, the presence of fruit is associated with the root of the tree, that is, with those that listen to the word, understand the word, and put it into practice. Jesus is clearly, and in a rather geometric way, our shelter from the wind, from the devilish wind, to be precise. Jesus' invitation for us to be part of his flock, at the root, may be seen in several passages. For instance, abandon yourself, pick up your cross, and follow me. Whoever loses his life for my sake will save it, and if a grain of wheat dies, it produces much fruit. In the summit of chaos, we may vividly differentiate the ever-intertwined wheat and chaff, and the corresponding gentle sheep and stubborn goats. There, in the preimages of zero, and in the same protection of the friends of Daniel, we may appreciate why, though 1,000 fall at your side, 10,000 at your right, near you it shall not come, as the psalmist proclaims. And in the dynamics of a strange attractor, we may get a glimpse of how God may imprison the haughty in the dust together, as he affirmed to Job, as a rather hellish and lonely punishment in the hidden world, where the ones trapped there never find each other. As the chaotic trees contain multitudes of thorns and no visible fruit, we may appreciate the curious but accurate quotation of Jesus when he said that people do not pick figs from thorn bushes. Also, as the notions hit to the root at zero, as a precursor of infinity in heaven, such allow us to visualize the power of sainthood in a geometric manner and consistent with Jesus' assertion that when 2 or 3 are gathered in his name, he is there in their midst. In love, then, 0 plus 0 equals infinity, as 1 plus 1 is equal to 1, as explained in the previous presentation. Finally, it ought to be emphasized, to make it really clear, that in the summit of chaos, it is indeed rather difficult to find the way to the root, for chaos is everywhere. As such, the middle point, the point and rather small gate expressing God's infinite mercy via purification, may be called the omega point, a term borrowed from Pierre Teilhard de Chardin, and a reminder that Jesus is the Alpha and the Omega, the beginning and the end, with no end. Now to end, and giving you thanks for your attention, I would like to share a poem in 2 languages, one entitled
Le plus improbable.
I hope you like it. In the highest ugly heat,
Sûrement misérable.
almost never a repeat,
Au détour incroyable.
sad travel with no rest,
Dynamique indésirable.
ever close to the best.
Étrange état exécrable.
In the most hellish beat,
Également déplorable.
a silly and vain defeat,
Périodicité interminable.
also spectacle disjoint,
Obstination réprochable.
an epsilon from the point,
Au hasard inévitable.
in the real driving seat,
Chaudement guérissable.
surely a fantastic feat,
Ô purgation ineffable.
a way to erected root,
Ô victoire admirable.
faithful relief and fruit.
Ô miracle vénérable.
In the symbolic tree,
Égoïsme détectable.
thorns dust in esprit,
Ô fractal pitoyable.
but in humble zero set,
Ô origine inégalable.
line cancels all depth.
Ô paradis inaltérable.
In the unbent choice,
Ô l'amour véritable,
always a clear voice,
ô poème formidable,
an appointed uplift,
miséricorde vérifiable,
deterministic a gift,
ô le plus improbable.
Thank you very much for your presence. For additional information, please refer to the book The Fig Tree and the Bell.